Let us take a look at an example problem that involves multiple processes. A piston cylinder device contains 5 kg of saturated water mixture at 125 kilopascal. Initially, 2 kg of water is in the liquid phase and the rest is in the vapor phase. At this point, the piston is resting on the set of stops. Heat is now transferred to the water, and the piston starts to move when the pressure inside reaches 300 kilopascal. Heat transfer continues until the total volume increases by 20%. Determine the initial and the final temperatures, the mass of the liquid water when the piston first starts moving, the work done during this process, and show the process on the PV diagram. We follow the same four-step process as identified in class. We want to identify the system, process, substance, fill the table, determine work, and apply the corresponding first law. Applying step 1. System is closed, so mass remains constant. The problem identified the substance as water. The processes involves multiple processes. We will talk about in the next slide and look at the motion of the piston and discuss why the processes are isochoric and isobaric. When the heating starts, the pressure will start to increase. As per problem statement, you will take an equivalent pressure of 300 kilopascal to raise the piston. The piston will stay on the stops and will move. As a result, this initial heating process will increase the pressure inside from 125 kilopascal to 300 kilopascal, and the piston will stay on the stops. At this particular point, the volume will not change, so we identify the process as isochoric. Now, once the pressure reaches 300 kilopascal, the piston will start to rise from the stops. When it's rising, it then becomes an isobaric process, since all forces acting on the piston remains constant. Thus, the pressure will remain constant. Thus, this problem is a multiple process problem consisting of an isochoric process followed by an isobaric process. In this case, the table is pretty easy to fill. We first separate the table into 3 states. State 1 is the initial state when the piston still sits on the stop. Step 2 is the second state when the piston starts to rise, and state 3 is the final state when the piston has risen to its final position. Two intensive properties are given in state 1. The 125 kilopascal. We know the liquid of the mass, or mass of the liquid. Therefore, we should be able to find quality. The phase is identified as saturated mixture. With the two intensive properties of pressure and quality given, we are able to find the rest of the properties from the thermal table. From the thermal table, we can interpolate temperature to be about 106 degrees C. From the processes, we can identify additional information for state 2. We're given that state 2 has pressure of 300 kilopascal. Since the process is isochoric, we can find volume. We know mass is constant since the system is closed. From volume and mass, we found that the specific volume is 0.825, which is the same as state 1. With two intensive properties, we should be able to find the missing properties in state 2. For state 3, the piston has risen, so the pressure is 300 kilopascal. The volume is given to be 20% increase, so it's 4.95 meter cube. Mass stays constant since system is closed. I can find my specific volume. With two intensive properties, I should be able to find the rest of the missing properties. Next step, we're ready to find the boundary work. We know boundary work is area under the curve. So how do we find the PV curve? We know the information of state 1. We know the process is isochoric. It is represented as a straight line from 1 to 2. 2 to 3 we understand is an isobaric process. And from 2 to 3 we can find the isobaric line to be horizontal case. The pressure at these given points are 125 kilopascal and 300 kilopascal. And from prior slides, we can find numbers for the volume as 4.127 and 4.953. And the unit of the volume is in meter cube. The area under the PV curve is then a rectangle area. Therefore, we can find the boundary work as area under the PV work, which is area of the rectangle. Width is width at 300 and height. The width being the difference between the two volumes and the height being 300. And we arrive at our final answer of 246.7 kilojoules. This slide shows now the completed table that we found that includes everything. And we're ready to apply the first law. All the numbers necessary for the first law are identified either on the table or found on the prior slide, the boundary work. Plugging in all the numbers, the total heat transfer is found to be 6,567.7 kilojoules.